Well, happy Friday, you guys. Sorry I'm not there. I'm in a conference right now, so I thought I could do the notes this way. We're pretty good at this. First of all, did you do the reading? If you did the reading, you might have gotten answers like this, okay? So the reading is, what is a system of linear equations? Set of two or more linear inequalities in the same variable. That was in the book. Step 2, what is the solution of a linear inequality? Well, we're going to graph, we're going to shade, we're going to shade again, and we're going to see where the shading of all graphs overlap. That will be the solution. Those are the only points that work for all graphs. Then how can you test the solution of a linear equality? We're going to plug in any point in any region, and if you get a true statement for all equations, then that has to be a solution in that region. Okay, so now let's take a look at the notes. So here we go. First of all, Common Core. Let's write this down. ARET stands for algebra, reasoning, equations. 6, solve systems of linear equations and inequalities with graphs. And that's exactly what we're going to do, okay? So I'll take a moment to go ahead and write that down. Solve systems of linear equations, inequalities with graphs. Solve systems of linear equations, inequalities with graphs. All right, so let's do this. Now we remember that two things. When we're doing less than or greater than, we're going to have to shade for sure. We know if it's has an equal sign, it's going to be a solid line. We know if there's not an equal sign, it's going to be dashed. Okay, so let's check it out. First of all, we've got two equations to graph, equation 1 and equation 2. So equation 1, we know how to graph that. It's got a y-intercept of 4, 1, 2, 3, 4, and a slope of -2. So go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And when I graph this line, I'm going to use a solid line because of the equal sign. So I'm going to make a solid line now. Okay. Now if I read this correctly, it says y is less than. So to be less than, I have to be under the graph. So if I shade under the graph, I have all of this. Okay, that's the first graph. Now if we graph the second graph, we should have some overlap. Okay, start at -3. We're going to go up 1 because it's a 1 over 1, up 1 over 1, up 1 over 1. Okay, and I'm going to make it a dashed line because there is no equal sign. So here we go. Now, let's read this carefully. It says we want to have a greater than, so we're going to shade everything above. All right. So we're looking for everything above our line. We're looking for where it overlaps. It turns out, if we look at this carefully, that both regions are going to overlap right in here. So I'm going to make this region darker than the rest. Now that is a solution. Now how do we test it? Well, I'm going to take a look at any point within the purple region. Any point. Well, for me, the easiest point has got to be 0, 0. I would test 0, 0. I could take any point in this region, but for me, I'm going to test 0, 0 because that's got to be by far the easiest point. So I've got to test it in both equations. So I've got a y is less than or equal to -2x plus 4, and I'll test y is greater than x minus 3, and I'll plug in any point in the purple region. Well, 0, 0 is the best one. xy, so I'll go 0 is less than or equal to -2 times 0 plus 4. I'll get 0 is less than or equal to 4, and that is very true. 0 is less than or equal to 4. Okay, region, the first equation works. Plug in 0, 0. 0 is greater than 0 minus 3. Of 0 is greater than -3. Yeah, that's true also, so it works. Anything in the purple region works. Now, we won't test these very often, but we can test them, right? All right, example 2. Let's graph the system of inequalities, all right? So again, we're just going to shade. I've got to remember, though, if I have to graph y equals 4, that is a horizontal line, straight across, up at 4. So I'll go up to 4. I'm going to draw a solid line, 1, 2, 3, 4. Draw a solid line right across the 4, okay? Now, I'm going to have to graph everything less than or equal to 4, so it's everything under. the whole region under. The next equation, I'm going to have to solve for y. Okay, solve for y. Alright, so solve for y with a 4x minus 2y is less than 6. Let's bring over the 4x, so I have to subtract the 4x. So I have a negative 2y is less than 6 minus 4x, because I need to subtract the 4x. Divide by a negative 2 all the way through, and when I divide by a negative, what happens? Divide by a negative, I'm going to turn my inequality sign, right? Because I divided by a negative. So I'm going to rewrite this as a y is greater than negative 3 plus 2x. Alright, I can graph that. Dashed line, it's going to be dashed because there's no equal sign here, so start at negative 3. 1, 2, 3. And I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And get my dashed line. And then I'm going to have it greater than or equal to, so I'm going to go everything above it. So I'm going to go greater than or equal to, it's going to be the entire region above this line. And what I'm looking for is where the two systems overlap in shading, which is going to be done in purple. All of that. There you go. Okay, pretty easy, right? And I'm not going to test a point. Now, example 3 has 4 different equalities. So what I'm going to do is I'm going to get some kind of shape, maybe a square, rectangle, maybe parallelogram, but I'm going to definitely get a shape. So let's go ahead and take a look at it. So first of all, if I had an x equals equation, like x equals negative 2, that is a vertical line. Okay, x equals are the straight up and down lines. So I'm going to go to negative 2, solid dot, shade straight up and down. Okay, that's going to be x is greater than or equal to negative 2. So that's going to shade that way. I'm not going to do all of it because I know the next one is going to be less than 3, so I'm going to put it in between negative 2 and 3. Okay, let's do that one. Let's do x is equal to 3, which is right here at 1, 2, 3. I'll draw a solid line. And so the graph is going to be greater than or equal to negative 2, but it's also going to be less than or equal to negative 3, so that shades that. So I get this region between negative 2 and 3 for the x values. Okay. Now, the third graph is going to be y is greater than or equal to a negative x plus 1. Okay, so that's a regular old linear equation. So start at 1. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay. Solid line, because it has its equal sign. Solid line. So I'm going to go ahead and graph that straight down. Now, I want greater than. So if I want greater than, I'm going to shade everything above this line. Okay, but so far I've got only overlapping in this region here. Okay, finally, let's graph the third equation. Y is less than or equal to 4. So that's a horizontal line. 1, 2, 3, 4. All right, straight across, and I'm going to go ahead and graph it at 4. Graph that in, and then I want it less than or equal to 4, so I shade everything below that. And now what I'm looking for is all of the regions where they overlap. Well, I've got orange, green, and yellow in this region right in here. Kind of a weird looking trap, but it is a trapezoid. There's my solution. Okay, kind of weird. Created a trapezoid with our graphs. Alright, you ready to do to the back? I'm going to turn it. We'll take a look at the back, which has a little bit of a story problem on it. Okay, so here we go. Okay, let's read this first, and then we'll try and figure out some things. Okay, so first of all, a polar expedition is 240 miles away from base camp, and a snowstorm is predicted to reach the camp in 48 hours. Okay, so here's some numbers I need. 240 miles, that's a distance. 40 hours, that's a time. So I'm thinking I'm going to need two equations. So I might need a distance equation and a time equation. So time, and I'll do a distance equation. All right, let's see if we can come up with things. Okay, so the expedition will travel as far as possible by boat. So maybe I've got boat and feet, and we're going to walk, so let me use variable, so let's let x equal be on foot. I'll let y be by boat. Alright? So what I've got is two variables. I've got x for foot, y for boat, and I'm going to have two equations, a time equation. So, first equation, equation 1 is time equation. I can either walk for so many miles, or so many hours, plus I can go by boat for so many hours, but I've got to get out of there by 48. So I can go less than or equal to 48. It's less than or equal to because the storm hits in 48. So if you get into camp before 48 hours, great, but you better not be after 48 hours, otherwise in trouble. Now the distance. Distance has to do with your rate. So we can go 3 miles per hour by foot. So I know distance times, rate times time is distance, so I'm going to go with 3x plus, in this case, the boat can go 12 miles per hour, so 12y. And in this case, we could go more than 240 miles an hour because we might go in circles, we might take diagonals, we might try and avoid all sorts of things like ice blocks. So this could be greater than or equal to my 240, okay? Now, what I want to do is try and graph this. And if I can graph this, then I can find all the possibilities that we can have. So before I graph it, let's go ahead and solve it. So equation 1, equation 2. Let's take equation 1 and solve for y, okay? So if I'm going to graph this, I got to solve for y. Here's my equation 1. Let's solve for y so I can graph it. So bring over the x of y is less than or equal to 48 minus x. And equation 2, I got a 3x plus a 12y is greater than or equal to 240. So again, let's solve for y. Let's bring over my 3x, so I have to subtract my 3x of a 12y. It's greater than or equal to a 240 minus my 3x. So I'm just taking my two equations, time equation, solving for y, my distance equation, solve for y, so divide by 12, and I will have a y is greater than or equal to, oh gosh, what's 240 divided by 12? I think it's 20, probably. 240 divided by 12, yeah, it's got to be 20, minus a 1/4 x, because I'm going to reduce this, okay? Now, my scales. I got to make my scale so it's going to fit. And so I'm thinking, okay, what can I do to make this fit? So if I go, oh, I could even go by 5s, couldn't I? I can go 10, 20, 30, 40, 50, same thing here, 10, 20, 30, 40, 50. Okay, now this has got to be walking because that's x. And this has got to be by boat because that's y, right? So let's try and graph these. So we're going to have to do our very best to try and estimate where we are. But first equation starts at 48. So 48 is about there. We're going to go down 1 over 1, down 1 over, so we'd intersect also at 48, okay? Down 1. I know if it starts at 48 here, and I go down 1 over 1, it's going to end at 48 here. It just makes sense, right? So I'm going to graph that in. Now, this equation is a less than or equal to, so I'm going to shade everything below it. So for my time equation, time's going to be shaded in green. Now I'm not going to shade in this region at all because that's negative time and negative distance, so I only include it in quadrant 1. Won't shade over here, won't shade over here because that's negative time. The other equation, we're going to start at 20. And I'm going to go down 1 over 4, down 1 over 4. I know I'm going down 5 over 20, but that's the same thing. Down 1 over 4, down 1 over 4. Okay, and I'm going to graph that in. This equation is greater than or equal to, so I shade everything above, okay? Now where I overlap is this region in here, and we'll just kind of darken that in purple, okay? That's my overlap. What does this region represent? Well, any point in this graph, like for instance 10:30, that point right there, for instance, means you can walk for 10 minutes, and then you could go by boat for 30, It's all the possibilities of being able to make it in 48 hours and still be able to make your distance, all right? That's what the overlapping means, okay? So here's your homework. I will be here tomorrow, or Monday, and please do your homework. 202, 3, 5, 7, 9, 26, 44, and 48. I expect you guys to work while I'm gone. I'll see you Monday.